Hello, welcome to LightBoard.
LightBoard allows you to record videos where you can see the presenter and the board writing, as well as overlay video, and also interact with PowerPoint slides.
Here are some examples of videos we record in the facility.
Question is number A. We are required to determine the yield strength, and as you all know, the strength or the stress of the material is the load over the original cross-sectional area. The load at the yield point is 98,000 Newton over the cross-sectional area, which is 200 millimeters squared, and that gives me 490 Newton per millimeter squared, which is mega Pascal.
Cwestiwn cyntaf I chi. Shwd mae'r tywydd heddi? Shwd mae'r tywydd heddi? How is the weather today? Shwd mae'r tywydd heddi? Oer. Mae hi'n oer heddi. Mae hi'n oer heddi. Mae hi'n oer. Eto? Mae hi'n oer heddi. Shwd ych chi'n dweud, how do you say, it's cold today? Da iawn. Mae hi'n oer heddi.
Now, that's a horrible expression. But we don't need to think about the general case, because if you think about how we apply this circuit, in general, little v, the difference input voltage, the voltage between these two inputs, is generally very small. It may be microvolts. And because it's such a small voltage, we can approximate it to 0. Let's see what the value of that expression would be when little v is close to 0. So let's do that.
So how to solve that? Solving a linear equation. In order to solve a linear equation, we try to make the unknown quantity the subject of the equation. The operations that can be used in the process of solving a linear equation are add or subtract the same quantity to both sides. Multiply or divide both sides by the same quantity. Take a function of both sides. For example, you can square both sides.
Let's start with what we have down here for alpha, which once it's cleared up a bit is 1 plus R4 over R3. And that's divided by R1 plus R2. That's alpha. And we know from, I'll have to pick one of these equations. So let's use the equation that I just had up there. I'll rewrite it over here. So when we compared the coefficients of V in, we had 1/4 equals the same coefficient of V in down here, which was alpha times R2.
If you'd like to use LightBoard, please get in touch at eng_lightboard@swansea.ac.uk.
Or you can visit the website swansea.ac.uk/engineering/lightboard, where you can see more information.